Hi students, today we are going to discuss discrete random variable. So first, what a random variable is. So a random variable is a variable whose values depends upon a chance or probability. So what we are saying is a variable whose values depends upon a chance or a probability is called a random variable. Let's discuss an example in order to understand this concept. This is very important concept in probability distributions. Suppose we throw a dice. Suppose we are playing a game. We are playing a Ludo, and while if we throw a dice, we may get 1, 2, 3, 4, 5 or 6. These are possible outcomes we can get. So every time number of boxes moved by a counter depends upon what we get on a dice. Suppose in my turn, if I get 4, I'm going to move my counter 4 times. If get 5, 1, 2, anything. So in every turn, the number of boxes moved is a variable entity. Obviously, it's not like you every time you're moving one counter or one box or 2 boxes or 3 boxes. Every time it is different. So that's why it is a variable value. Why it is discrete? Because you move either 2, 3, 4, 5 or 6. Now, when it is your turn, you throw a dice, and every time it depends on what you are getting on your dice. So if you're getting 1, 2, 3, 4, 5. So every time number of boxes moved by counter depends upon what we get on the dice. If we get 1, 2, 3 or 4. So this movement is a variable. So in your next turn, the number of boxes moved is a variable entity, and this could be 1, 2, 3, 4, 5 or 6. Okay, and how many boxes you are going to move is depending upon a probability. So we say that this variable, number of boxes moved, is a variable and its values are 1, 2, 3, 4, 5, 6. These are possible values. Now let's come to this table. If we throw a dice, we can get 1, 2, 3, 4, 5 or 6, or in my next term, number of boxes moved is a random variable x. Okay, we are representing x as a random variable. Now x is a random variable. So x is equal to 1, 2, 3, 4, 5 or 6. So what is probability of 1 while throwing a dice? It's 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6 and 1 by 6. So this specific table or probability distribution in general is listing of all elements, a listing of all possible values of, I would say, listing of all possible values of a random variable and its probabilities is called probability distribution table. So what is a probability distribution table? Listing of all possible values of a random variable, and against each value, if we write its probabilities, this is known as probability distribution table, right? So random variable is a variable whose values is depending upon a chance. I hope you got this. Let's do a question. For example, if I am asked to toss a coin twice, or 2 coins are tossed, and x be a random variable, we have defined x as a random variable. Let x be a random variable, and what it shows is the number of heads obtained. Draw probability distribution table. We need to draw a probability distribution table. So x is equal to 0, x is equal to 1 and x is equal to 2. What do we mean by this? X is equal to 0 means we get no heads. X is equal to 1 means we get 1 heads. X is equal to 2 means we get 2 heads, right? So in order to complete this probability distribution table, it's always great to draw a tree diagram. So let's draw a tree diagram. This is heads and tails. We have to toss coin twice, or we are tossing 2 coins, so it's 1 by 2 and 1 by 2. This will be your first, and for second it's heads and its tails, 1 by 2, 1 by 2, and same, it's heads and tails, 1 by 2 and 1 by 2. What are my possible answers? Heads, tails, that is equal to 1 by 2 into 1 by 2, that is equal to 1 by 4. Similarly, heads, sorry, this was heads and heads, heads and heads, heads and tail, it is 1 by 2 into 1 by 2, head and tail. Similarly, third could be tail head, that is again 1 by 2 into 1 by 2, and that is tail and tail, that is equal to 1 by 2 into 1 by 2. Now first of all, when we have no heads given means we have only tail and tail, so that is equal to 1 by 2 into 1 by 2, that is equal to 1 divided by 4, so this is 1 divided by 4, right? Let me change the color. Okay, second one is, it says we have one head means okay, now what are the possible answers? We may have heads and tails, or we may have tails and heads. So one head means probability of heads and tails plus probabilities of tails and heads, so that is equal to 1 by 2 into 1 by 2 plus it's 1 by 2 into 1 by 2, that is equal to 1 by 4 plus 1 by 4, that is equal to 1 by 2, so it is 1 divided by 2, and the x is equal to 2, random variable takes value 2. What do you mean by this? What do you mean by this? X is equal to 2, we have 2 heads, so probability of head and head, that is equal to 1 by 2 into 1 by 2, that is equal to 1 by 4, so we list 1 by 4 here. So that's how we complete a probability distribution table, and random variable will be defined in question mostly. Okay, so in this part, a bag contains 3 red marbles and 5 green marbles. We have 3 red marbles and 5 green marbles. 2 marbles are selected at random without a replacement. Okay, and now let x is the random variable, represent number of green marbles selected. So we have defined initially x is equal to number of green marbles selected, number of green marbles selected. Draw probability distribution table to represent the data. So now what are the possible outcomes we may have? X can be 0, 1 or 2. Okay, when we say x is equal to 0, what do we mean? We have no green marbles, no green marble given. Okay, and that would be x is equal to 1, that will be 1 green marble selected out of 2, 1 green marble, and then x is equal to 2, x is equal to 2 will represent 2 green marbles, 2 green marbles are selected. Now how are we going to solve this thing? Let's draw our tree diagram, and we have 3 red marbles and 5 green marbles. So red and green, and then it's going to be red and green, red and green. Okay guys, you need to realize this thing, remember this thing, that this is without replacement. What marble we are selecting, we are not putting it back. Okay, so we have 3 red, so it is going to be 3 by 8 and 5 by 8. Now this was the first trial. When we take second marble out, now we have 2 red marbles out of 7 and we have 5 red marbles out of 7. Similarly, if first is green, now we have 4 green left out of 7 and still 3 red out of 7. So my possibilities, what we can get is red and red, red and green, green and red, green and green. So these are possible answers we may get. So red and red would be 3 by 8 into 2 by 7. We know that concept of and R we multiply probabilities. Red and green, this is going to be 3 by 8 into 5 by 7. Then third one is green and red, that is 5 by 8 into 3 divided by 7, and the fourth one is 5 by 8 into 4 by 7. Now these are possible options that we have. Now let's come back to putting the values and draw our probability distribution table here. So first of all, x equals to 0. What do we mean by x is equal to 0? We have no green marble. That means both marbles are red and red. So probability of red and red is this 3 by 8 into 2 by 7, right? So that is going to be 6 divided by 56. Second, x is equal to 1. That means we have one green marble. So one green marble is coming here, and here there is a concept of OR. So that will be probability of green and red, or probability of red and green. So we are going to apply this concept in this way, that green and red is 5 by 8 into 3 by 7, 5 by 8 into 3 by 7, plus red and green, that is 3 by 8 into 5 by 7, right? And this is going to be 56, 30 divided by 56, right? Now x is equal to 2. That means we have two green marbles, so green and green. So green and green has probability 5 by 8 into 4 by 7, that is equal to 20 divided by 56, right? Now let's draw a probability distribution table and list all possible values there, and against it its probabilities. So now the x that is representing a random variable, number of green marbles, can take the values of x, can take value 0, 1 and 2. So probability that this x will become 0 will take value as x as 0. So here you go, that is equal to 6 divided by 56. For 1 it is 30 divided by 56, and this is 20 divided by 56. So this is required probability distribution table for this question. Probability distribution table. You need to recall one more thing, that sum of all probabilities is equal to 1. So this plus this plus this will be equal to 1. So remember that sum of all probabilities is always equal to 1 from probability distribution table. Okay. So I hope you got the idea. In this question, have a look. This was like probability distribution. We need to draw a probability distribution table of a scenario in which we have a bag that contains 3 red and 5 green marbles. 2 marbles are selected at random without replacement. Let x is a random variable that represents number of green marbles selected. We need to draw a probability distribution table to represent the data. So x initially was number of green marbles selected. So we say that this random variable will take value 0, 1 or 2, right? And then if x is 0, that means we will not get any green marble. That means both are red, 1 and 2. And then we draw tree diagram for this. You can do it without tree diagram as well, by the way. And then listing all possible values of random variable and against it all probabilities, and this is known as probability distribution table. We know that sum of all these probabilities is equal to 1. So yes. Let's move to next question now, and just a minute. In this question, we have the probability distribution of a random variable x is given in the following table. So in this question, they have made the distribution table, probability distribution table, and we just need to find value of p and find the probability that x is between 2 and 5. So since it is discrete and this is greater and this is less, so we'll be taking values of 3 and 4 only. Anyways, first of all, in this solution we know that sum of all probabilities is equal to 1. So let's solve it. Sum of all probabilities is equal to 1. That means p plus 2p plus half p plus 3p, that is equal to 1. So in order to add all these, it's basically that is going to be 2. It's 2p plus 2p plus p plus 6p is equal to 1. And now we have 4, 5, it's 11p by 2 is equal to 1. So p is equal to 2 divided by 11. So that is value of p first of all. In second case, part B, what we are looking for, probability of x is between 2 and 5. So that means probability of x is equal to 3 plus probability of x is equal to 5. See, we cannot take values of 2 and 5 since it is greater and less only, not less and equal. So that's why. And probability of x is equal to 3, that is equal to 2p, p is 2 by 11, plus probability of x is equal to 4, that is half p, half of 2 by 11, and that is going to be 4 by 11 plus 1 by 11, that is equal to 5 divided by 11 is my answer for this question. I hope you got it. Okay, after understanding the basic concept of discrete random variable, we are now going to discuss expectation and variance of standard variable, second discrete variable, that is basically, suppose we have a random variable whose values are possible 1, 2, 3, 4, 5 and 6. This is again the same question. If we have a dice and we can have these possible values of a random variable 1, 2, 3, 4, 5, 6, and expected value will be given by this formula, sum of x into p. So this is formula for expected value. Okay, this is usually mean. You could say it, this is basically mean. Okay, now let's calculate for this question. Expected value is equal to, it's 1 into 1 by 6, that you multiply random variable into its possible probability, plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6. So that is equal to, it's 1 plus 2 plus 3 plus 4 plus 6, that is equal to 10, 15, 16, 17, 18, 19, 20, 21 divided by 6, that is equal to 3.5 expected value for this data. So E of x for this data we get is 3.5, right? Second formula that we discuss here is for variance. Now for variance we have, let's have the same question, the same table we have, and yes, now formula for variance of x will be equal to sum of x square into p minus ex whole square, right? Now how do we do this? We're going to take square of every x values. You can even make a separate bar here, a column here with this, so that will be representing it. For example, we may have ex, yes, for example we have to draw x square on the same table, right? And this is going to be x square, so it's 1, 4, 9, 16, 25 and 36. So we have sum of x square into p, so it's 1 into 1 by 6, you are multiplying this with probability, okay, plus 4 into 1 by 6 plus 9 into 1 by 6 plus 16 into 1 by 6 plus 25 into 1 by 6 plus 36 into 1 by 6 minus e of x that we have just calculated here. It is 3.5 square. So variance of x of a discrete random variable will be equal to, just a minute, let me calculate it. It is going to be, if we add all these things, it's 91 upon 6 minus 3.5 square, and that becomes 3.42. Now 3.42 is variance of this data, and we know that standard deviation is basically square root of variance. So for the same data, if you need to find standard deviation as well, that is 3.42. So root 1.849 or 1.85 is the standard deviation. So in this part we discussed expected value, expectations, and a variance of discrete random variable. That's how we do it. If we have probability distribution table, expected value is always equal to summation x into p. Okay, we are going to multiply every random variable value with its probability and add these all, we get expected value, and formula for variance is summation x square p minus some e x whole square. So we need to, sometimes we need to make a separate table in this given table, probability distribution table, and you find x square values and add these with after multiplying with probabilities, and minus 3.5, that is expected value square. Standard deviation is square root of variance.